elastic collision, kinetic energy of the system will be conserved. That is, whatever kinetic energy was before collision, same will be kinetic energy after collision. Linear momentum is conserved in all the, whatever the type of collision may be, whether it is any physical contact or only it has crossed the field of influence, like collision of fundamental particle, alpha particle and nucleus of the gold. So that is also collision. So law of conservation of momentum is valid for all type of collision, whereas kinetic energy is conserved only in case of elastic collision. So today we will derive the expression for velocity of the two particles after collision in case of elastic collision only. So when the collision is elastic, what will be the velocity? Velocity of particles after suffering elastic collision. So for our convenience, we are taking both the objects are moving in same direction. Okay, this is suppose with velocity u1, this is with velocity u2, its mass is m1, its mass is m2. This u1 is more than u2. The magnitude of u1 is more than u2. They are moving in same line. Sometime what will be, one is going from this side, other is coming from that side. So we have to consider the vector only. So here u1 and u2 both will have same direction, that is same. If this u1 you are taking positive, if this direction you are taking positive, this is also positive. But if one is coming from this side, another is coming from this side, suppose this is u1, this is u2, then what will be? When we are saying linear momentum, then linear momentum is m1 u1 vector sum. So what will be the magnitude actually? Momentum of this minus momentum of this, because they are opposite. Vector sum. The two vectors are opposite to each other. So always keep in mind, whatever we are going to derive, that is, we have to apply the concept of vector. Simply, we will not add or subtract the magnitude. If addition or subtraction is coming, not only the magnitude, you have to consider direction also. So suppose after traveling some distance, these two has collided. When u1 is more than u2, magnitude of u1 more than u2, then these two have, this ball has struck this. Now during some time there is interaction between them. This is applying force on this, this is applying force on this, and finally these two are separated. This is with velocity v2, this is with velocity v1. Okay. For our convenience, we have taken all are in same direction. If direction is opposite, naturally you have to consider, we have to add like vector. So one law, that is law of conservation, is valid. So according to law of conservation of linear momentum, or applying law of conservation of linear momentum. If you are asked derivation, then we will say, let us consider two particles m1 and m2 moving with speed or velocity u1 and u2 in same direction. u1 is more than u2. Let they collide. They remain in contact for some time. During this period, each will apply force on other, and finally they are separated. So after collision, let the velocity, their velocity be v1 and v2 respectively. If derivation is asked, you are supposed to write like this. Now if we apply law of conservation of linear momentum, what will be this m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. This is for whatever what type of collision may be. This relation is valid. In all the type of collision, one relation will be common, this one. Now, as the collision is elastic, so kinetic energy is also conserved. So as the collision is elastic, so kinetic energy of the system is also conserved. So what will you get? So half m1 u1 square plus half m2 u2 square will be equal to half m1 v1 square plus half m2 v2 square. This is total kinetic energy before collision. This is total kinetic energy after collision. So in case of elastic collision, these two are equal. If the collision is inelastic, this one will be more than this. A part of initial kinetic energy will be transformed into some other form. Maybe heat, maybe sound, or maybe heat and sound both. That will be, the mechanical energy will be transformed into some other form. Naturally, kinetic energy, final kinetic energy will be less. And sometimes the difference of these two kinetic energy we call Q of a collision. So this Q of collision, that is final kinetic energy of system minus initial kinetic energy. So this Q will be 0 for elastic collision. Q will be negative for inelastic collision. Where final kinetic energy will always be less. Okay, so from here this half will be cancelled. So what we are getting, suppose this is M1 and from this side we are taking M1 this side. So M1 U1 square minus V1 square is equal to M2. This one we take this side. V2 square minus U2 square. M1 U1 plus V1, we can say like this vector, into U1 minus V1 will be equal to M2 V2 plus U2 . So it will be better if we this one's little you modify it. So if this one M1 we are taking common, what will come? U1 minus V1 M2 V2 minus U2. This will be our equation number 1, not this one. Now, if you divide this second by first, what we will get? So this second divided by first will give, what is that here? M1 U1 minus V1. So M1 U1 minus V1, and this side is M2 V2 minus U2. So this will be cancelled. So what is left? U1 plus V1 will be equal to, this is cancelled, so V2 plus U2. Or this U1 minus V1 is equal to V2 minus, sorry, U1 minus U2, V2 minus V1. This we have already got by using coefficient of restitution also. So if you are not interested in this part, if you don't want to write like this, directly you can write this one. As we know, for elastic collision, velocity of separation is equal to velocity of approach. So directly we can write like this equation. This is velocity of approach, this is velocity of separation. So without doing this, you can do like that, no problem. Now, these two equations we got. We have to find this V2 and V1. And so we'll use this again. Okay, that will be better. This one you write first, this one you write second, this one you write third, this one you write fourth. So here will be dividing third by second. If you are not using the concept of kinetic energy is conserved, directly you want to write, that, as we know, for elastic collision, velocity of approach is equal to velocity of separation. Then this is your equation number 1, and this one will come equation number 2. 3, 4, no need. Second and third will not come. So this will be 1 and this one will be 2 direct. You are free, you can use that concept also. But in the syllabus it is especially mentioned, don't use coefficient of restitution. So you are supposed to do this way. But if you are doing like that, no problem. So now we will use this equation number 1 and 2 to find V2 and V1. How will you do? How will you find? These are the two equations now. If you want to find the value of V2, then V1 should be cancelled. How V1 will be cancelled? If you multiply this by M1 and then add with this. So this equation 4 is multiplied by M1 and then we are adding equation number 1. What will you get? So this is M1 U1 minus M1 U2 equal to M1 V2 minus M1 V1. All are vector only. So this fourth one is multiplied by M1. Now we'll add this one. M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. We are adding these two. This is cancelled. So what will you get? Twice M1 U1 plus U2 if you are taking common, then M2 minus M1, or if you are taking minus, then M1 minus M2. You are free, you can write like that also. You can give positive sign, you can give negative sign, no problem. And this is equal to how much? V2 we are taking common, then M1 plus M2. So what will get V2? So this V2 will be twice M1 by M1 plus M2. So this is our V2. So what? Fourth one was multiplied by M1. Now how will find V1? So to find V1, we have to remove this V2. So we'll multiply the fourth equation by M2. So we'll multiply fourth one by M2. And then we will M2 is here positive, and there it was. What was coming? U1 minus U2 is V2 minus V1. Okay. So if you are taking this one, we will add, then this one will be cancelled. So we will subtract. Okay. So this equation 1, from equation 1 we will subtract this. So equation 1 is, okay, M1 V1 plus M2 V2 equal to M1 U1 plus M2 U2. You can write this side also, no problem. Now fourth one, equation was this one, we have multiplied it by M2. So it will come M2 V2 minus M1 V1, sorry, M2 V1 will be equal to M2 U1 minus M2 U2. We will subtract it. So this is cancelled. So we are getting M1 plus M2 V1. Now M1 U1 will take common, then what will come? M1 minus M2 U1 plus twice M2 U2. V1. So this V1 will be, come this side. So twice M2 by M1 plus M2. U2. Plus M1 minus M2 by M1 plus M2. U1. We want to write in the same form, that is here negative is coming. So can we write here minus sign? Then what will come? So V1 is twice m2 by m1 plus m2 u2 minus m2 minus m1. So see, what is the similarity in these two equations? If you interchange the position of m1, m2, u1, u2, you will get the same thing. Here it is m1, there it is coming m2. u1, there it is coming u2. Here m1 minus m2, there m2 minus m1. u2, u1. If you interchange here, no problem. In place of m1 plus m2, you can write m2 plus m1, no problem. So if one of the velocity you got, second one you can get by interchanging the position of m1, m2 and u1, u2. So by this we will not learn this formula. Simply derivation is asked, then only we will derive. To solve the numerical, we will not use this formula, or it is very difficult to learn, or some mistake may happen. So while solving the numerical, we will use only two things. We will apply law of conservation of linear momentum, and then velocity of separation equal to velocity of approach, or kinetic energy conservation you will apply. Only these two things we will apply. So this is velocity of the two particles after collision in case of suffering elastic collision. Now some special cases may be, what, time up or what? Yes, already time up, no. Okay, then we leave up to here. Next stage. So all are sleeping or what? I don't understand. No response, nothing is coming. I'm not happy with you all. Then from next day I will put the video completely on, so that anyone can be brought on the screen and others will see what are you doing. So from next day be ready. You put your video on, only mic will be off, so that anyone can be brought anytime on the screen. And then we will see what are you doing. This is not good thing. No response is coming from you.